Imagine a world where the past, the present, and the future exist simultaneously. Welcome to the fascinating realm of time travel. This concept, so prevalent in our popular culture, tantalizes us with the possibility of revisiting history, or perhaps catching a glimpse of the distant future. And it's not just the stuff of science fiction. Scientific theories, most notably Einstein's theory of relativity, provide intriguing insights that suggest time travel might not be entirely out of reach. But is time travel really possible? Let's dive into the world of Einstein's theory of relativity to find out. Picture a train, not your ordinary train, but one that travels around our planet at near the speed of light. This is no ordinary journey, but a voyage into the future, a thought experiment that brings us face to face with Albert Einstein's general theory of relativity. Imagine you're a passenger on this fantastical train. As it hurtles around the Earth at almost the speed of light, something extraordinary happens. Time starts to slow down. But this isn't due to any mechanical failure or some sci-fi trickery. It's a very real phenomenon known as time dilation. Time dilation, as predicted by Einstein's theory, explains that the faster an object moves, the slower time appears to pass for it compared to a stationary observer. So, as your train races near light speed, time inside the train seems to slow down relative to time on Earth. This isn't just theoretical musing either. Real-world experiments have confirmed this mind-bending effect. Consider the case of precise atomic clocks flown on satellites. These clocks, much like our train passengers, are moving at high speeds relative to us on Earth. And just like our theoretical train, these clocks experience time dilation. They tick slower than identical clocks on Earth, losing about 45 microseconds every day. Now let's return to our train. As it continues its near light speed journey, the passengers feel time passing normally. They might read a book, take a nap, or enjoy a meal. But when they step off the train, they're in for a shock. What felt like a few hours on the train was actually several years for the people on Earth. When the passengers finally step off the train, they find that while only a few hours have passed for them, several years have passed on Earth. They have, in essence, traveled into the future. Now, what about the past? Can we ever revisit yesteryears? This is a question that has sparked the imagination of scientists, philosophers, and dreamers alike. According to the equations of general relativity, time travel to the past is theoretically possible under certain extreme conditions. One condition could be faster than light travel. Imagine if we could travel at such a speed that we could outpace light. In theory, this could allow us to see into the past, as we'd be catching up to light that left Earth years ago. However, as exciting as this may sound, it's important to remember that faster than light travel is currently beyond our scientific capabilities and may always remain so. Another condition could be the existence of wormholes, hypothetical tunnels through the fabric of space-time. If wormholes do exist and we could navigate them, they might serve as shortcuts that could theoretically allow us to travel back in time. But again, the existence of wormholes is purely theoretical at this point. Even if they do exist, they may not be stable or large enough for humans to travel through. There are many scientific and philosophical challenges with the concept of past time travel. For instance, the infamous grandfather paradox suggests that if a person were to go back in time and alter the past, it could create a contradiction in the timeline. This paradox, and others like it, raise difficult questions about causality and the nature of reality itself. Despite these challenges, the idea of past time travel continues to captivate us. It's a tantalizing possibility that pushes the boundaries of our understanding and challenges us to rethink what we know about the universe. Past time travel remains an open question, a tantalizing possibility that continues to challenge our understanding of the universe. Time travel, as intriguing as it is, comes with its fair share of paradoxes and conundrums. One such paradox is the infamous grandfather paradox. Imagine you traveled back in time and accidentally altered the course of events in a way that prevents your own existence. If you were never born, how could you have traveled back in time in the first place? This paradox raises significant conceptual challenges. Then there's the bootstrap paradox, a situation where an object or piece of information sent back in time becomes trapped within an infinite cause-effect loop. How can something exist without having been created? Despite these paradoxes, the allure of time travel remains. The prospect of exploring the past or witnessing the future continues to captivate our collective curiosity. Understanding the nature of time could unlock new frontiers in science, perhaps even redefine our perception of reality. So, is time travel truly within our grasp? Or is it just a captivating figment of our collective imagination? The answer remains elusive, but the quest to understand time continues to push the boundaries of our knowledge and understanding.